Okay, today we're looking at graphing and writing the equation of the line. If you had Math 0300 here at Wesleyan, we went over this last semester, so this will be a quick review. But if not, I'm going to go ahead and start at the basics and make sure that everybody understands how these works. Now, if you haven't downloaded this note sheet, I just made this up even for the students in class, just because it's hard to graph without graph paper. So this has graph paper for you, and then you can do your practice problems here on this worksheet. But before I start the worksheet, I want to talk about the very basics of graphing. So I just made a little sketch of a graph here. And so this is called a Cartesian graph. And you know where the two numbers intersect is always the origin, or the point 0, 0. And on this is the x-axis, and this is the y-axis. And so always think of x as the same as like the horizontal number line, and y is the one that goes up and down. And if you can't remember which one's which, just think of the letter y goes up and down. So that's the up and down one, and the x is the horizontal one. And so after 0, 0, then of course it goes positive numbers to the right and negative numbers to the left, just like on the number line. And then on the y-axis, positive numbers up and negative numbers down. Now, when you're graphing on actual graph paper, you don't have to label your points and anything. I can just count the squares. But if you're making your own graph, if you're doing it on notebook paper and you didn't run this off, be sure, you don't have to write all the numbers, but be sure to show me some of the numbers so I'll know that you graphed it correctly. Okay, and then we have what's called an ordered pair. And that's a parentheses with two numbers inside of it, and they're always separated by a comma. The first number is always your x, and the second number is always your y. It's alphabetical order, so that's an easy way to remember that. And that tells you where you're going to go on your graph. So if you had the ordered pair 2, 3, this tells you want to go 2 on the x-axis and then 3 on the y-axis. And you do both of those things before you draw a point. So it's kind of like giving you directions where you go 2 blocks and then you turn left and go 3 blocks. Like you don't reach the destination until you do both of those things. And so to get to the point 2, 3, I would start at 0. I would go to 2 on the x-axis, and then up 3 on the y-axis, and where those two intersect is your point. That's the point 2, 3. And actually Google Maps is based, this is called a Cartesian graph. Google Maps is based on Cartesian graphs. I'm sorry, just your house has a coordinate of points, where you're going has a coordinate of points, and the computer is just going to use the mapped out area of your town to tell you how to get from one point to the other. So a lot of things are based on graphing. So let's try another one. Let's try the point, let's do the point -3, 1. So for that one, I would start at 0. I would go to -3 on the x and then +1 on the y. And once you have 2 points, you can draw a line. Let me extend this a little bit. Okay, and then the next thing I want to talk to you about is x-intercept and y-intercept. So an x-intercept is where it crosses the x-axis. So like in football, when you say there's an interception, that means that's where the player intercepted the ball or stopped the ball's line of pathway. So the word means the same thing in well, it came from math before football, but it's where the x-axis intercepts that line. And I didn't draw this really to scale here very well, but it crosses, let's say, right here, and that's at the point -6. So the x-intercept for this line is -6. And the point for that, do you see your x is always first and your y is always second? So the point of that would be -6, 0. You would go to the left 6 and up or down 0. So that's the x-intercept. And then the y-intercept is where it crosses the y-axis. And so that would be right here. And we're just estimating here because I just did a little sketch. You won't have any fractions on your worksheet. But So here, the y-intercept is y equals, let's say that's 2.5. And the point for that would be 0, 2.5. So y-intercepts are important because you see with zeros are the easiest thing to plug in formulas because 0 times anything is just 0. So when we go to graph our lines, we're going to use y-intercepts because you probably learned back in high school to make an XY chart and they would give you all these numbers. I taught high school, so I remember those books. And you had to plug them in. But which were the two you liked the most? The 0 was the easiest one, and then you would go to 1 would be the next easiest one. But here in college, we want the easiest way about this, so we're just going to use the zeros. We're going to let x equals 0 and solve for y, and then we're going to let y equal 0 and solve for x. Okay, so let's go to our worksheet, and I'll tell you what I mean. So this says graph 2x plus 3y equals 6 by x and y intercepts. And so what that means is we're going to make our little chart like we talked about before, but instead of putting a bunch of numbers for x and solving for y, we're going to let x equal 0 and solve for y. And then we're going to let y equal 0 and solve for x. And that will give us our 2 points, and 2 points make a line. And so what makes this easy is when you let x equal 0, so you don't have to really show this step. Let me do it in another colored pencil. But when you put in 0 for x, you end up with this. And no matter what is in front of here, 2 times 0 is just 0. 0 times anything is 0. So what that does is get rid of the x value. So when you let x equal 0, your x goes away, and all you have to solve is this 3y equals 6. And so 3y equals 6, you would just divide by 3 and get y equals 2. So when x is 0, y is 2. Now what makes this even better is you really can do all this just by looking at it. You don't even have to show any work because when x is 0, cover up your x value because we have 0 x's, so the x's are gone. And then it's just 3y equals 6. You're always going to divide by the number in front of y. So the shortcut is just to say 6 divided by 3 is 2. Then we're going to let y equal 0. Let me get another pen. Which means cover up the y value. And do you see you have left 2x equals 6. Or 6 divided by 2 is 3. And so now we have our 2 points. We have the point 0, 2. Which means go 0 on the x-axis, but 2 on the y. Remember, this is your y and this is your x. Or just think 2 on the y-axis. And then we have 3 on the x-axis, because the point 3, 0 means go over 3 and up or down 0. 2 points make a line. So we are finished. So it's just a quick, easy way to graph a line. Now remember to always put the little arrows on the ends to show that it keeps going on forever. And so we graph the line. But now we're going to talk about domain and range. We didn't have this in 0300, but domain means what values are used on the x-axis. And range means what values are used on the y-axis. But when you have just a regular line like this one, do you see it continues on forever into infinity with both x and y? So anytime you just have a regular straight line, I'll show you the exceptions to this, but the domain is always negative infinity to infinity, and the range is always negative infinity to infinity, which means on x it goes from negative infinity all the way into positive infinity, and for y it goes from negative infinity all the way into positive infinity. And so that's graphing using x and y intercepts. Okay, now let's look at number 2, which is graphing using slope intercept. So for x and y intercepts, you just draw your xy chart, and you let x equal 0 and solve for y, and then y equals 0 and solve for x. But number 2 says to graph using slope intercept. So you also have this note sheet to download, and you can keep this with you during your test and everything if you want to. So these are all the formulas that you need for graphing. And we'll talk about slope here in a minute, but it's telling us to graph using slope intercept. So this is slope intercept form right here. And it's just put it in the form of y equals mx plus b. And so when it's in this order, the number in front of the x is the slope, and the number at the end is your y intercept, where it crosses the y axis. So when we look at this first one, the first thing we have to do, let me get this, well, I'll put it, trying to get it on camera, is get it in this form right here. We want it to look like that y equals mx plus b. So to do that, we've got to solve for y. So here's my equation, and so we need to get y by itself. So to do that, I need to first move so I want it to look like this, y equals mx plus b. So the first thing I need to do is move my 2x to the other side. And remember, anytime you go over the equal, you do the opposite. So it's like subtracting a 2x from both sides. So that would leave me 3y equals a negative 2x plus 6. I'm going to put it in the front because I wanted x and then the number. And then to get y by itself there, I would just need to divide everything by 3, which would leave me, y equals a negative 2/3 x plus 2, because 6 divided by 3 is 2. And so now that it's in that form, using our formula here, it tells me the number in front of the x is your slope, and the number at the end is your y-intercept. So looking at this one, this is my y-intercept, and this is my slope. So the y-intercept's easy. The y-intercept is just where it crosses the y-axis. So remember, this is your y and this is your x. So it's saying the y-intercept is at positive 2. So that one's pretty easy to graph. But then we look at the slope, and from our formula here, you see that m always stands for slope, and slope is equal to rise over run. So rise means how far do you go up or down, and run means left or right. So up is positive, down is negative, left is negative, right is positive, just like we talked about on the Cartesian graph. Remember, to the right is positive, left is negative, up is positive, down is negative. So this one is a negative 2/3. So what that means is you want to go down 2 and then to the right 3. I really should put it on here. So this tells you want to go down 2 and to the right 3, because the negative tells you to go down. If it was positive 2, you'd go up, and the positive 3 tells you to go to the right. Now you don't start from 0. You go to your y-intercept, which is 2. So you keep your pen here, because really you don't have to show any work. You're just looking at it. I'm just writing stuff down because I'm helping with you. So you go to the y-intercept of positive 2. You keep your pen there. And then the slope tells me to go down 2. So I went down 2 boxes, and then to the right 1, 2, 3. And once you do both of those things, you draw your other point, and there you have your line. And so domain is negative infinity to infinity, and range is negative infinity to infinity, because it's just a normal linear line that extends on into infinity. But I want you to see what we did is we actually graphed the same thing 2 different ways. So this way we did it by x and y intercepts, and this way we did it by slope intercept. You get the same answer no matter which way you graph it. And on your test, I'll just tell you to graph. You can choose which way you like better. I will say this way more people make mistakes with their negatives and getting things messed up. So, I mean, I do feel like this is the quicker, easier way in this instance, and really the way people make the least amount of mistakes. So in my opinion, if it's not solved for y, it's not in slope intercept form, so this way is easier. But if you look at this next one, we'll do it both ways, and you'll see that probably the slope intercept form is easier. In fact, we'll start with that one. Do you see this is already in slope intercept form, y equals x plus b. So this one's actually easier to graph by slope intercept because you can just look at it. So my slope, my y-intercept is 4, so I go up to 4, draw a point. My slope is a negative. Now your negative can be on the top or the bottom, it doesn't really matter, but it can't be both. It's not a negative 1 over a negative 3, because that would actually be a positive 1/3. So I just always put it on the top. If you just think of the negative is telling you to go down, and a positive is telling you to go up. So it's really just down 1 and to the right 3. And remember, it's from this point. So from this point, I'm going to go down 1, and then to the right 3. 2 points make our line, so we can connect it. And our domain and range is negative infinity to infinity, negative infinity to infinity. I know those infinities are hard to draw, even for me. Got to kind of concentrate on them. If you can't draw them, you can always just do 2 circles together. That's fine too. Or scribble. I'll know what you're talking about. So this one was quick and easy by slope-intercept form. But let me just show you that you can graph this one by x and y intercepts also. So let's look at it that way. So for x and y intercepts, I'm going to draw my xy chart in my 0, 0. And so when x is 0, that one's pretty easy. I cover up the x value, and you see I have left just y equals 4. So that one's pretty easy. The problem comes when y is 0. So when you cover up y, do you see that equal sign's right there? So really, this one you do have to do some work, because what you've got is 0 equals a negative 1/3 x plus 4. So we need to get our x on the other side. So remember, and you don't have to show all this step. You can really just move it over. When you move x over the equal sign, it changes sign. So I get a 1/3 x equals 4. And then to get x by itself, I need to multiply both sides by 3. So x equals 12. So when y is 0, x is 12. So to graph this one, we have the point 0, 4, or 4 on the y-axis. And we have the point 12, 0, or 12 on the x-axis. Now it's going to be way off of here because that's 10. Wait, is that 10, 1? Yeah, 10, 11, 12, one more. And so here's our line. Domain is still negative infinity, infinity. Range is still negative infinity to infinity. But you see, even though this one would continue on forever, they're the exact same line. But of course, this way was much easier. So if you want to graph quickly without having to show a lot of work, here's kind of the key in my opinion. If it's not solved for y, do you see how this one's not solved for y? Then xy intercept is easier. If it is solved for y, like these two, then slope intercept is easier because it's already in the form. So it's kind of like if it's, this is really silly, but this kind of helps me remember. If x and y are on the same side, think x and y intercept. If y is all by itself, then think slope intercept form, just for the easiest. But again, you can graph them all by one form, and that's perfectly okay. I'm just kind of telling you which ones I think are quicker and easier by which method. Okay, so then next we have kind of the exception to every rule. And so this one is kind of a special case because of this 0 here. And so you can actually choose whichever way you think is easier to do this one. I kind of have my opinion about which one's easier. But let's look at this one both ways. So let's do this one by x and y intercepts. So if I do it by x and y intercepts, when y equals 0, you cover up the y. But you see what happens here is 0 divided by negative 2 is 0. So I got a 0 there. Then when I let y equal 0, I cover up my y. But you see that 0 divided by negative 2 is 0. So when you do this one by x and y intercepts, you only get 1 point. You just get the point 0, 0. So that is a point, but we need 2 points to make a line. So for this case, you have to pick one other point, and it can be any point you want. Usually the next easiest point is 1. So if I plug in 1 here for x, I would get y minus 2 times 1 equals 0, or y minus 2 equals 0, or add my 2, y equals 2. So when x is 1, y is 2. Now remember, you have to do both of those directions to get to the point. So I have to go 1 on the x and then 2 on the y. So I start at 0, I go over 1 and then up 2. 2 points make a line. So we've got our answer. Remember, domain negative infinity to infinity, range negative infinity to infinity, just because it's a straight line that goes on for infinity. Not a straight line, a linear line that goes on for infinity. So it wasn't horrible, and again, that happens because of this 0 here. So this is by x and y intercepts, but let's look at it by slope intercept. I think slope intercept's easier on this one, but again, it can be your choice there. So for slope-intercept, I need to get y by itself and my 2x on the other, because remember we're using this formula. We want it to be y equals mx plus b. So all you have to do is move the 2x over. Remember, it's like adding a 2x to each side. So we get y equals 2x plus 0. So comparing it to the formula here, let me put the formula up here. Whoops, can't get it on the camera there, and there we go. My y-intercept is 0. This is my y-intercept. And my slope is 2, but slope has to be a fraction. So anytime you need something to be a fraction, you can put it over 1 to make it a fraction. So to graph this one, we go to the y-intercept, which is 0. And then the slope is, see, this one's a positive, so we're going to go up 2 and over 1. If it's negative, you go down. If it's positive, you go up. So there's our line. And just like before, domain's negative infinity to infinity. Range is negative infinity to infinity. Same line. So you could do it either way. In my opinion, this way's a little faster and easier. But again, they work either way. Let's turn the page. And so now let's look at these on the back. So these are two other special cases. These are actually the easier ones. Most people don't miss these at all. But this first one just says, well, let's graph this one first because this one's actually already in form. So do you see that it says graph y equals -3? You can't do an XY chart because there's not an X and Y. You can't put it in slope-intercept form because there's no slope. And so what that's telling you is that you're going to go to -3 on the y-axis. Now you do have to remember this is y and this is x. So I'm going to go to -3 on the y-axis and draw a perpendicular line to that y-axis. And that's your graph. What it's saying is that no matter what x is, y is always -3. If x is -4, y is -3. If x is 5, y is -3. No matter what x is, y is always -3. And this is a horizontal line, so this is where domain and range are going to change. And I just realized I didn't talk a lot about domain and range before, but this is kind of where it'll make a difference. So domain is all of your x values, and range is all of your y values. So when you have a regular line like these over here, it's just negative infinity to infinity because x and y keeps going on forever in both directions. But on these two specialized, it only goes to infinity in one direction. And so if you look at this, y is never anything up here. Y can't be 4, y can't be 9, y can't be down here in the negatives. Y is always -3. So since range is your y values, your range is just -3. That's all y can be. It can't be anything else. But you see the x values go forever in this direction and forever in that direction. So your domain is negative infinity to infinity. So whichever letter this is equal to, that's going to be your domain, or your range. I'm sorry. If it's y, it's domain. Over here is x, so it's going to be range. So think domain is x, range is y. If you can't remember which one's which, alphabetical order. D comes before R, x comes before y. Domain is your x values, and range is your y values. So let's look at this other one. This one says graph x plus 3 equals 7. Again, we can't put it in the other form to graph it because we don't have a y. You have to have an x and a y to graph the lines we did before. This just has an x, so we need to get x by itself by moving our 3 over and getting x equals 4. Then we go to 4 on the x-axis. Remember, this is your x, so 1, 2, 3, 4 on the x-axis. You can't draw a line that way because it would be the x-axis, so you always do it perpendicular to the axis you want to drive it at. I mean, you want to draw it to. And so this is a vertical line through x equals 4. And so remember, x is domain, so your domain is 4, and then your range is negative infinity to infinity. So for a regular line, you see these lines go, you know, positive or negative, but they're not, they're just linear lines, I'm sorry. Your domain is always negative infinity to infinity, and your range is negative infinity to infinity. But with these two special lines, when you have a vertical line or a horizontal line, your domain is going to change. Because this is just x equals, then the domain is 4. And because this is y equals, the range is -3. And then the other one is the negative infinity to infinity. Okay, so this is such a long video, so we're stopping there. This is 7.1, and we'll finish the rest of this note sheet in the next class. So we're going to do 7.2 right here. But flip over in this note sheet to the next page, and you see it says problems from 7.1, work on your own. So your practice problems for tonight are 1 through, let's see, 1, 2, 3, 4. 1 through 8. So today's practice problems are just 1 through 8, and that's practicing graphing the graphs 2 different ways. And so they should come out the same graph, and that'll let you know if you know how to do them correctly both ways. So practice problems for 7.1 is 1 through 8.